Today we're going to demonstrate how to calibrate a sample drawing gas detector. In this case it's a RKI Eagle 2 gas detector, using a 3-gas mix cylinder and an ACD Cal2000 hydrogen sulfide gas generator. We're going to take the 3-gas mix and put a sample draw demand flow regulator on it. We're going to turn on the Cal2000 instrument, and when we turn it on, we're going to set the flow to 0. So when it comes up and asks us for flow rate, we'll set the flow to 0. That'll allow us to draw the sample out of the instrument without fighting the pump in the RKI Eagle 2. So that says flow rate 0.5, and we're going to turn that down to 0. Now the Cal2000 instrument is going to wait for us to have some type of flow now, so it's going to ask us to stabilize the flow. So we'll take the output of the 3-gas mix and put it into the Cal2000, and then we need to put a hose between the sample drawing RKI Eagle 2 and the Cal2000 instrument. I've got a hose here I'll hook up. So here the pump for this whole system is going to be the RKI Eagle 2, and it's going to pull the sample out of the 3-gas mix and out of the Cal2000. The instrument immediately goes into alarm, so I'm going to put it in the calibration mode so it doesn't make any more noise. So we'll go to, we can do this however we want. We'll go to a single gas calibration, and I'll just pick one gas at a time. Methane gas, and this cylinder contains 50% LEL methane. So the instrument's asking me what the target gas is, and the last time it was calibrated it was 50% LEL methane. So I'll just enter that value. Now it shows you the reading. It's reading 31% LEL. When it's stabilized, we'll enter that value and it'll adjust the span value up to 50. So it's, again, that's pulling out of this cylinder through the Cal2000, out of the Cal2000 and into the instrument. Well, we haven't had any change in output for about a minute here. So now we're going to enter that value and it'll adjust it to 50% LEL. Okay, I wasn't sure it grabbed and I wasn't looking, so it's still creeping up a little. I'm going to do it one more time. It's reading slightly high. Alright, so now that'll adjust it from 53% LEL down to 50. I'm going to select the next gas. We'll do carbon monoxide next. This cylinder contains 100 ppm of carbon monoxide, so I'll adjust the calibration gas value to 100 to match whatever my cylinder is. If it had 50, you'd use 50. If it had 200, you use 200. Whatever your calibration gas cylinder is what you tell the instrument it's looking for. And now you see this instrument, this sensor is pretty well stable because it's been flowing this carbon monoxide the whole time we've been talking. It's bouncing between 53 and 58 parts per million. And so since it's stable, I'll enter that, and it's going to fail its calibration. Looks like maybe we've got a bad CO sensor. I'll try it one more time. So here's the real life scenario. The CO sensor fails, and we probably are going to have to replace it. Yeah. Okay. Now we're going to move on to the H2S sensor, and we'll come back and replace that CO sensor and then recalibrate it. The H2S is looking for 25 parts per million. So now I will adjust the output of the Cal2000 to 25 parts per million. That's a good number to use. Oh, I leave the flow at 0. Then I change the output and select 25 here. Went past it. Now it will stabilize. And you'll see the output on the sensor start coming up. I'll select that. Now it's reading. And here you'll see an example of how quickly this Cal2000 comes up. And then when it gets up to 25 parts per million, or wherever it stabilizes, because this unit here hasn't been calibrated in a long time, we'll accept the calibration and move on. Like I mentioned, we'll have to go back and replace that carbon monoxide sensor for this instrument. Just turn that on so I can have backlight again. It's like a very low sensor again. Let's see if this one calibrates. It might fail as well. It made it. I'm gonna run out to the normal mode and see if the sensors, they're all receiving gas still, so they should all read the correct calibration concentrations that we've used before I dump out of this calibration. Oops. Come around here. So you see the methane's reading 48% LEL, oxygen's at 20.9, H2S is 29, and CO is 53. So I'll reset that H2S. It did creep up a little bit. And then, as I mentioned, in real life here, we'd have to go replace the CO sensor and then repeat the process for that. Let me get out of here again. See if the H2S is reading on. It's going to beep at us in normal operation. Then we have a unit that's pretty well calibrated, but the CO sensor needs to be replaced. When you're done with that, you just unplug the instrument, you unplug the cylinder, and when you power off the Cal2000 instrument, it will purge itself. So now the pump kicks on, purges out all the H2S out of the system, and then the instrument will shut itself off. And this eagle is still purging itself, the LEL is still coming slowly down. And that's the basics of how to calibrate a sample draw unit using a Cal2000 and a 3-gas cylinder mix.